Alright, there's some fragmentations that aren't listed in your book, and I'm not going to talk, well, I'm going to mention in lecture, but I wanted to give you a video presentation of these types of fragmentations. I consider them important. You're going to see them on the math specs that you're going to run into over the course of the semester, so I wanted to at least explain what you're going to be seeing. And the first types of fragmentation that you're going to see are the general fragmentation, and those ones are going to be based on radical stability. So you're looking at things where tertiary is more stable than secondary, is more stable than primary, more stable than methyl. Things that are aryl are going to be pretty stable. Things that are phenyl are going to be pretty stable. That type of thing. So if there's anything that's going to stabilize a radical that's associated with that, that is also going to make something more stable. All right? Now, moving on, I want to talk about things that also make fragments and mass spec more common. And the first one that you're going to see is alpha cleavage. Alpha cleavage is the separation of a bond that's alpha to any sort of functional group. So here I've got this heteroatom, oxygen, okay, attached to a carbon. Anytime you see a heteroatom, you're going to expect some kind of alpha cleavage. And the alpha cleavage occurs in this location. It also occurs in this location. Okay? So an alpha cleavage, what I expect to see is this type of cleavage. I expect to see one of the R groups that's attached to a carbonyl or attached to an alcohol be broken off. The more stable this thing is, the more likely it's going to break off and be formed. Okay, so if this is secondary or tertiary, we would see a lot of this type of fragmentation. If this is primary or methyl, we're not going to see as much of that type of fragmentation as we'd expect to see. Okay, and again, just as a reminder, this can be positive as well, and that can be a radical. So I expect to see both peaks generated during this type of alpha cleavage. Okay, common things that go through alpha cleavage are carbonyl compounds, any heteroatom, so S, chlorine, nitrogen. Oxygen's the big one. Okay, we always see some sort of alpha cleavage whenever there's an oxygen involved. The next type of cleavage that we expect to see is loss of water. If there's a way for an oxygen to reach out and grab a hydrogen and then fragment, it's possible. And this happens if the molecule itself can wrap itself to a position so that the oxygen, this alcohol, can reach out and grab another hydrogen that's near a carbon. If it can do that, if the molecule is big enough to do that, it's quite possible that you're going to see the loss of 18 mass units from the parent ion. And that loss of 18 indicates a loss of water. Okay, it's quite common. And you end up with the radical cation here at the end and a loss of water. This will undergo additional fragmentation as well. But notice in this case we have very select locations of where the radical and where the cation is going to be. And again, this could be radical and that could be cation as well. Right? The last type of fragmentation that we expect to see is something called a McLafferty rearrangement. And McLafferty is when I've got a carbonyl in this location and that oxygen comes out and grabs that hydrogen. This hydrogen has to be 6 atoms away. Notice if I count here, I've got 1, 2, 3, 4, 5, 6. That is a 6-membered ring, and those things are very, very stable and very, very common in organic chemistry. Okay? So now, this oxygen reaches out, grabs that hydrogen. This comes down, forms a double bond between these two carbons, kicks out these electrons over here. Okay? What we're left with is this type of form, where we're going to have an enol. All right, enol is generated, and again, this is the radical carbocation. And over on this side, I've got a double bond being formed. And this thing generally doesn't have a charge, so we're just looking at this thing and a loss of whatever is over on this side. Okay, so these are the things that we're typing to see. These are the common types of fragmentations that we see, and these are the things that you really have to know. So yes, you do have to know these things, even though they're not in the book, and there's no real problems associated with it. Because we're going to see these all the time, you have to know what these types of fragmentations are and how they occur.